Hello students, for this week I want to focus on revision. I want to focus on getting you guys ready for IA2, which is your summative internal assessment. By now, you should have had a good look at all the learning material up to this point. And before you keep watching the video, I want you to have a really good attempt at the practice exam first. It's defeating the purpose if you're just watching the video and copy down the answers. That's not going to help you out. Have a really good go at solving those questions yourselves first before using my lesson to revise, to pick up on what you have missed and to clear up some misunderstanding. So the vote for today's lesson, we are to revise for IA2. Okay, so let's look at how we can solve A. We're adding two terms together. You can see an x here, you can see an x here. We're adding them together is a sum. If we add them together, if we need to differentiate this whole thing, we need to differentiate the first term and we need to differentiate the second term and then add them up. So by now you should be very familiar with how to differentiate this. If you can't remember the formula, always go back to your formula sheet. This is your best friend. Remember to use it all the time and be familiar with what's on there. So if I need to differentiate f of x, we write f dash x, we would differentiate this whole thing. Cos would become negative sine. We keep what's in there the same, take 5, but then we also need to times it by the derivative of what's inside the bracket. In this case, 3x takes 5, if you derive it, it becomes 3, times it by 3. Let's look at the second term, e to the power of 2x. If we want to differentiate an exponential function, it stays the same, but in this case, it is an e to the power of 2x. So which rule do we have to use? Exactly, we need to use chain rule, okay? So that becomes plus e to the power of 2x. We need to multiply it by the derivative of 2x, which is just 2, times 2. Okay, and then you can tidy it up a little bit, equals to negative 3 sine 3x take 5 plus 2 e to the power of 2x. Alright, now we're going to look at B. We want to differentiate f of x equals to x to the power of 3 times natural log of 2x, or ln 2x. So you can see we've got x here, we've got x here. We are timesing them together. Which rule would we use if we want to differentiate? We're going to use the product rule. Okay? So f of x would equal to u dash v plus u v dash. Okay, I wrote too hard on this pen. So, the easy way to demonstrate your understanding would be, right, you're going to call u, let's call u x to the power of 3, and then we're going to call v equals to ln 2x. So you're going to use u dash equals to, well, 3x squared, and v dash would equal to, well, ln would become 1 over whatever is inside, but we need to apply the chain rule, which means we need to times it by the derivative of what's inside, which is 2. The 2's will cancel out, leaving you with just 1 over x. So everything you need is there. Now you just need to put everything back into this form. Okay? So f dash x equals to u dash v, so it's 3x squared. V is just ln 2x plus u in this case is x to the power of 3 and v dash would be 1 over x. Okay? So, tidy it up a little bit. The first thing, you can't simplify anymore. But the x cubed and x, you can cancel one of the x's out, leaving you with plus x squared. That's how you would do it. Okay, let's look at C. You've got an x term up the top, you've got x down the bottom, you're dividing one by another. Which rule would we use? The obvious one to use would be the quotient rule to differentiate. Okay? If you don't remember it, that's fine. That formula would be on your formula sheet. Make sure you check, don't make any silly errors. If you mix your u's and the v's, your answers would be incorrect. So, f dash of u over v would be u dash v, take u v dash over v squared. Okay? So we're going to call the top bit u. So we're going to let u equals to e for x. And if you differentiate u, you're going to get 4e to the power 4x. I'm not going to slow down on how to differentiate those things. You should have done that to death. And then I'm going to let v equals to the bottom bit cos 4x. Therefore, v dash is going to become, I'll bring what's inside, the derivative inside out. 4 cos will become a sine, so negative 4 sine 4x. Okay? So everything I need to populate this formula is here. Now let's just put it all together. So f dash x equals to u dash, which is 4e 4x, v, which is just cos 4x. Take away u, which is e to the power 4x, and v dash, which is negative 4 sine 4x. Everything over v square, which is cos square 4x. Okay? Now we just need to tidy it up. You don't need to do much here. 4e 4x cos 4x. This, you need to clean it up a little bit more. I've got a negative multiplied by a negative, it becomes a positive. Bring the 4 up the front. 4e 4x sine 4x over cos square 4x. If you want to clean it up a little bit more, you may, because you've got the common factors here, cos 4x and cos square 4x. One of these terms can cancel out. But if you write it up to here, you would have got it perfectly correct. But if you want to clean it up a little bit more, you may. 4e to the power 4x. One of the cos's would cancel out. So this guy would be gone over cos 4x. But the second term, you can't really cancel anything out. So it will become 4e 4x sine 4x over cos square 4x. Okay, so I'm going to accept either one of those answers. You don't have to, if you get up to here, that's good enough. If you get up to here, that's also good enough. Alright? Okay, let's look at this last one. Okay, which rule would we use? By now you should know we're going to use the chain rule. Right? So we need to know, we can call u what's inside a bracket, 3x squared, take 5. Differentiate u, you're going to get 6x. So, when you want to differentiate a function of a function, you need to first differentiate that function. So first, f dash x, so you need to differentiate ln. What is the derivative of ln? Well, it becomes 1 over x, right? Or 1 over whatever's inside the bracket. 5, you can leave it where it is, times 1 over 3x squared, take 5. Am I done? No, because we still have to multiply that whole thing by u dash. So I'm going to times it by 6x. And now you just need to tidy it all up. Equals to 30x over 3x, take 5. Can I simplify it any more? No, I can't. That's all we can do. So this would be my final answer. So f dash equals to 30x over 3x squared, take 5. Alright, I'm going to really quickly go through 2a and 2b because they are the relatively more simple questions. This equation is written in log form. I need it to be in a form that I can easily solve it. When we say we want to solve a function, we want to find a number representing x. So I need to write that in a form that we can use. Okay, so we know 2a, you can rewrite that as 3x equals to, this is the base, 6 to the power of 2. Okay, so you can write it that way. And now it's super easy to solve. 6 squared is just 36. Divide both sides by 3. 36 divided by 3, your answer will be 12. You shouldn't spend a lot of time on this question in an exam. If you are finding yourself spending too much time when you're doing the practice exam, you know that you need to do more practice. Let's look at B. What are the clues here? What can we do? Well, one big clue here is they have the same base. So we're going to use one of the log laws to help us out. If we have the same base, and then you're plussing two logs together, you can combine them together by multiplying what's inside the bracket together. If you're not sure about that law, again, go back to your textbook, go back to your notes, or go back to your formula sheet. So that will become log k 5 times 2x. Some people always make the mistake by adding those two together. That's incorrect. You times them together. 5 times 2x equals to 0. So obviously that becomes 10x equals to 0. You rewrite it in a form that we can use. 10x equals to k raised to the power of 0. If you raise anything to the power of 0, what would that become? If you're saying 0, you're incorrect. It should be 1. Alright? So now, the last step is super simple. Which you want to solve for k, divide both sides by 10. Your answer should be 1 over 10. Okay, so I'm going to work on C. I've got 81 to the power of 3x, take 1 equals to 9. By this point, you need to be very sharp with our numbers. At the moment, they are in a different base. I can't really do much. But you should be able to see, okay, 81 and 9, what's common about those two numbers? 3. You should be able to identify, okay, actually 81 is just the same as 3 to the power of 4. Okay? And then 9 is just 3 squared. So you can rewrite that, and then things will look a little bit more optimistic. So let's replace 81 by 3 to the power of 4. 3x take 1, and then you're going to rewrite 9 as 3 squared. Now we're getting close. I need to have both of these to be under the same base. Remember our index laws. If you're raising a power of power, you just times the two powers together. So I can just times this 4 by 3x take 1. So I can rewrite this as 3. 4, 3x take 1 equals to 3 squared. So now both of these are under the same base. I can just equate the powers together. So it will just be simple solving this equation. So 3x take 1 equals to 2 divided by 4 becomes a half. Right, 3x equals to a half plus 1, so it becomes 3 over 2. And then divide both sides by 3, x equals 3 over 2. So your answer should be a half. Always check your answers at the end. Alright, so what you need to do is sub in a half into x and see if you're going to get the same answer. If you get the same answer, you know that you've done it right. Alright, let's look at D. How will we solve D? We need to, well, we did put it in the form that is solvable. At the moment, these 2's are not helping. I need to somehow work the 2 with what's inside the bracket. You need to remember which log can we use. Right, now would be the one that has got to do with the power. We can chuck this in the bracket. That would become ln x plus 3 square. Take ln 4 equals to ln 3 squared. Or if you want to be super accurate, you can put a, well, bracket around it. Next, now it is coming more and more obvious of what we can do next. I'm minusing 2 logs, same base, turn it into division. ln x plus 3 squared over 4 equals to ln 9. Okay, next step, that's the easy part now. Both ln, nothing stuck to it, we can equate what's inside the bracket. X plus 3 squared over 4 equals to 9. Now it is just a simple equation to solve. Okay? X plus 3 squared equals to 9 times 4, 36. So x plus 3 would be, you need to take the square root of both sides, square root of 36. What is the square root of 36? Is it just 6? If your answer is just 6, you've missed out half of the points. Because when you take a square root, it's gonna be, always gonna be plus and minus. Alright? Because negative 6 times negative 6, you will get 36 as well. So your answer should be plus or minus 6. So solve for x. X can be, if x is negative 6, take 3, you're going to get negative 9. Or, if x is positive 6, and then you take 3, you're going to get 3. So you should write your answer is x equals to 3 or negative 9. But let's look at E. For this question, you have to be a little bit clever about it. If you observe this equation, it looks a bit like a quadratic equation. So what we're going to do is we can call e to the power of 2x u. Well, we're going to call ex u. That's what I'm going to do. If I call ex equals to u, this will become u squared, right? This will become take 2u, take 8 equals to 0. How do we solve it? We factorize. Okay? So I want to put them in 2 separate brackets. Probably negative 4 plus 2. That's just my shortcut of doing it. So we know u take 4 times u plus 2 equals to 0. So now we need to solve for u. So we have 2 answers. U can be 4 or U can be -2. But what exactly was U? U was just e to the power of x. So I'm going to sub it back. Ex equals to 4 or ex equals to -2. If I need to solve for x, I need x to be by itself. I don't want x to be stuck with anything. I want x to be linear by itself. How do I get rid of this e? Well, I take the natural log of both sides. That becomes x. That becomes ln 4. For this guy, what would this guy become? Ex to the power of -2. Well, you can't solve it. There's no solution here. It doesn't make sense. It's undefined. So in this case, it's undefined. So your answer will just be x to the power of, x equals to ln 4. Because in this case, there's no solution. Alright, so let's go on to integration. We'll look at 3a. Now we're looking at definite integral. By now, you should have done these to death. I'm not going to spend too much time going through it. I'm just going to step you through what you need to do. Okay, we need to integrate each of these terms. Comes x to the power 4 divided by 4 plus 2x, you raise the power, becomes square, and then divided by 2. The 3 will become 3x plus the c. And because it is a definite integral, we use the square brackets, 1 and 2. Let's tidy this up a little bit. So this guy would become x to the power 4 over 4 plus x squared, take 3x plus c, 1 and 2. Next is the part that a few of you make some silly errors. What you need to do is you need to sub in the 2 into x. Then you need to take away this whole thing when you sub 1 into x. Okay? Because this is in the non-calculated part of the exam, a lot of you are losing silly points because you can't do these super simple calculations. Okay? Make sure you don't make these silly mistakes. So, this guy would become 2 to the power 4 over 4 plus 2 squared, take 3 times 2 plus c, but then you're going to take away the c, I'm just going to ignore the c. Take away, you sub in 1, so 1/4 plus 1, take 3 plus c, I'm just going to ignore the c. So this whole thing, if you have done it properly, that should become 2. Take away, this will become -7 over 4. 2 negatives becomes plus, 2 plus 7 over 4. Your answer should be 3 3/4. Okay? That's how you do it. Again, don't make silly errors here. 2 to the power 4 is not 2 times 4. It's 2 times 2 times 2 times 2. Okay, please don't make these year 7 mistakes. Alright, so now we are going to integrate between 0 and pi over 2 of 6 times sine 3x. So obviously you need to integrate this stuff. You should have done this to death by now. That's going to become 6 times 1/3. Sine will become negative cos 3x plus c, but I wouldn't bother putting in plus c because you will end up minusing the c anyway. From 0 to pi over 2. Clean this stuff a little bit, that becomes -2 cos 3x, 0 pi over 2. Okay, so now I need to sub in pi over 2 into x. Then I need to sub in 0 to x, take away 1 from the other. So that will become 2, negative 2 cos 3 pi over 2. Okay? Take away negative 2 cos 0. Alright. So, this is the part that a lot of you might be stuck. What is the exact value for cos 3 pi over 2? If you can't remember it, maybe plot yourself a graph. Or maybe some of you might prefer to think about it in degrees. Right? If pi is 180 degrees, 3 pi over 2 would just be 270 degrees. Or if you think in radian, maybe you can just plot yourself. Okay, what does a cos curve look like? Well, cos starts here, and it goes back up here. I know this is going to be 90 degrees, this is 180, this is 270, or this is 360. And we know 360 is just 2 pi. This will be 1.5 pi, which is just 3 pi over 2. So we know cos 3 pi over 2 is just 0. So this whole thing becomes 0. What about cos 0? Well, let's look at cos 0 is 1. Alright? So this bit will become 1. So what we are going to have is, this whole thing becomes 0 because cos 3 pi over 2 is 0. This is 0. So we would have 0, take away 2 times 1. Right? 2 negatives becomes a positive. 2 times 1 is just 2. Your answer would be 2. So you must, by now, you should know the exact values of these commonly used values. Right? Not just for cos, you need to know it for sine as well. Let's look at question 4. I want you to find the turning point of this function below, justifying your procedures and decisions. Meaning, in this question, you need to clearly explain what you're thinking. You need to clearly explain to me the steps that you have taken and why you have chosen certain things. What is a turning point of a function? Well, if you've got a function and then I've got a turning point, the turning point means, what does it mean? If you can write it down, that would be great. And I want you to think about what would be the gradient at the turning point. So, at a turning point, we know the gradient of the function should be 0. Right? Regardless of what my graph looks like, if it's turning, I know it could be like this, that would be the turning point. So if it's like this, that would be the turning point. Right? Gradient is 0. If we are trying to find the gradient, what do we need? The derivative. So gradient of the function is 0, or we can say f dash equal to 0 at the turning point. So what we need to do is we need to differentiate this function. So we need to find f dash of x. Alright, how do we do that? This function looks really scary, but if you really look at it, this bit, what is it? 1 over 2 pi. Is that a variable? No, it's just a constant. It's just a number. Just because there's a pi there, it doesn't make it any more difficult than it is. It's just a number. We treat it like a number. You can see in this function, x only happens once. You can only see 1x here. So it's a very easy function to differentiate. It's just e to the power of all that. And then, in front of it, there's a constant. Right? Pi is not a variable. pi is not scary. Pi is just a number. It's just a constant. So to differentiate this, we're going to keep whatever out there the same, right? So you're going to have e. If you differentiate e, it becomes everything is the same. Then you need to times it by the derivative of that, which is will be negative 2 over 2 x, right? The 2 and the 2 will cancel, leaving you with negative x. So to write it a little bit nicer, you're going to have negative x over 2 pi e to the power of half x squared. Okay, so your first part is done. So now you have found f dash, but have you answered the question yet? Well, no, I haven't. The question is asking me, where is the turning point? Okay, so I need to know what x is and what y is at the turning point. I know the derivative now. Have a think about how you're going to do it. Okay, so now we know the derivative equals to 0. You should remember that's a law that we have been using all the time when we are solving equations. It's called the null factor law. Basically, this is a fancy way of saying if AB equals to 0, then A equals to 0 or B equals to 0. Pretty much common sense. If one of these is 0, your answer would be 0. So just like what we have here, we've got this chunk times by this chunk. So you have two options. You either this bit equals to 0 or this bit equals to 0. So let's just say if negative x over 2 pi equals to 0, you solve for x. X, well, times both sides by root 2 pi divided by negative 1, x equals to 0. Or this bit can equal to 0. But do we have a solution here? No, you won't have a solution. This bit is undefined. There's no solution. Okay? Because if you take the ln of 0, it's undefined. You can't solve this bit. So there's only one turning point. And that turning point would be at 0. Because for this bit can't equal to 0. This bit can be 0. And there's only one turning point at x equals to 0. Are we done? We're nearly there. We need x and we also need y. So we sub this back into the original equation, and then we will know what y is, or f of 0 is. So turning point is at 0, and you just need to sub in 1 over 2 pi e to the power of 0. But what's e to the power of 0? It's just 1. So it equals to 0, 1 over 2 pi. And that's all. That's how you do this question. Okay, you see, you have explained all the procedures and decisions. You have explained, okay, in this case, I can't accept this bit. This bit is 0. This bit is undefined. So there's only one solution for this to be 0. And then I'm stepping out, I'm clearly explaining myself, how did I come to this? I'm explaining to the marker, okay, I know at the turning point, the derivative has to be 0. I'm explaining to the marker, if AB equals to 0, either one of these would be 0. Okay? So if the question is specifically asking you to justify your steps, make sure you are justifying and explaining your steps. Alright, let's do one more. Last one. I want you to differentiate this sine x over cos x, and I want you to show that this equals to 1 over cos square of x. You should have done this to death by now. If you're differentiating something divided by something, you're going to use the quotient rule. So I know y dash is going to be u dash v, take uv dash over v squared. I'm going to let u equals to sine x, right? And then u dash will be cos x. And v would be cos x, v dash is negative sine x. We've got everything here. Now let's just put everything onto the equation. So u dash is cos x, v is just cos x, take away u is sine x, v dash is negative sine x, over v squared, which is cos square x. Alright, cos x times cos x becomes cos square x, negative sine x times negative sine x, two negatives becomes positive sine square over x, cos square x. Well, you can see I'm getting really close. The bottom bit match. What about the top bit? Can you see this is a special identity? We call it the Pythagorean identity. It's not in your formula sheet, but you should know it by now. Cos square x plus sine square x equals to 1. Okay? Pythagorean identity. Okay? Because this is the case, so alright, so you have proven that is in fact true. Okay, so let's look at part B. It's asking you to find the gradient of y equals to tan x. You might wonder, where the hell did this tan x come from? We never talked about tan before. Where did this tan come from? You need to remember by now, tan is just sine divided by cos. Please remember it. I know it is not on your formula sheet, but it is implied knowledge. So, before you have already worked out this is, or it has already given you this is the derivative of tan x. Pretty much this is saying the derivative of tan x is 1 over cos square x. So all you need to do is to sub in x equals to pi over 4 into the derivative function. Right? So y dash equals to 1 over cos square x. But if you can write it as y dash at pi over 4 equals to 1 over cos square pi over 4. Okay, so some of you will get stuck here if you don't have a calculator. Go back to your year 11 maths when we talk about the unit circle, right? You need to give us, to work out the exact value when you're costing something, when you're taking a sine of something. So, unit circle, how does it work? Draw yourself a triangle. Right? And then I would have 1 and 1 on these two sides. We know for these sort of triangles, if this is a right angle, these would be 45 degrees, which is just pi over 4. Okay? And using Pythagoras, you know this side is going to be root 2. So, SOHCAHTOA, right? We know cos is adjacent over hypotenuse. Okay, so cos pi over 4 would be adjacent, which is 1 over hypotenuse, which is root 2. So if you can't remember it, quickly draw yourself a these triangles, and then you should be able to work out the exact value. But hopefully by now you would have done these questions so many times that you don't need to do that. But if you have to, just quickly draw yourself a triangle and work it out. So cos pi over 4 adjacent over hypotenuse 1 over root 2. Okay? So that becomes 1 over root 2, but don't forget we're squaring it. If you're squaring 1 over root 2, that becomes 1 divided by 1 over 2, and your answer would be 2. Okay? So, the takeaway from this question is, there's a lot of assumed knowledge in this question. You're meant to know the Pythagorean identity. Cos square plus sine square equals to 1. You're meant to know tan is sine divided by cos. And you're also meant to know, okay, some of the exact values of trig functions. If you can't remember that, well, draw yourself a triangle and work it out. Or some of you might draw yourself a cos curve and then work it out from there. Either way, you need to know those concepts.